Hey guys, this is Mainak, and today we are going to design a residential building in Etabs. So this is going to be a complete course. I have made many videos earlier also, but in this video it is going to be the complete package. And if you are watching it for the first time, all the things will be necessary. Even if you are designing Etabs for the first time, we'll have a plan and we'll have all the detailed steps so that you will be familiarized with Etabs and as well as all the common loads associated with IS code for a residential building, that is RCC residential building. So let's start. So what will we cover? So we'll cover the modeling part, the load application part, and then we'll go structural analysis, and then that is the structural detailing. So these are the steps which will be covered in this particular course. And then we have the architectural plan. You can take a screenshot of this plan. In fact, I'll just zoom in for you a little bit in detail so that you can take a screenshot of this. This is the ground floor plan here. uh, in fact, I'll also provide a PDF if required in the link in the description, so that you can have a proper view of this, or you can take a screenshot if it's feasible. Okay, so this is the ground floor plan and first floor plan, and we'll make a G+2 building from here. Okay, so this is the case. And then before designing a project, you need to know some information of the project. So what are they? So we have the concrete M20, which you'll use, and steel FE550. And steel FE550's properties I have taken it out from the common steel available. And the initial sections, whenever you design a building, we have to take some initial sections, and if it passes, then it's okay. If it doesn't pass, then we can decrease the size. So these are the sizes which we'll take for our sections here. This is for the roof beam. We can take a little bit smaller sections, maybe 250 into 350 for our plain beam. Slab is 125 mm thick, and location is in zone 5, seismic zone 5. Our building location is in Agartala, Tripura. And then when you open it as, what are the steps? First of all, there is modeling part, and in fact I say that the steps in modeling are almost the same in all the softwares. First we'll define grids. If you don't import the grids, we can import the grids also. You can see in earlier videos of mine in the Etabs playlist. Define, you can then we have to define material, we have to define section, we have to model all the floors. If there is a balcony, we have to model the balcony, assign supports. If there is a tie beam required, we will model tie beam. And if in some cases there are some porch or balcony also, if you lower the tie beam, you lower the tie beam also. And then if you want to model the staircase landing beam, obviously we have to model that. And if you want to provide just UDL, you can do that, or else you can model the staircase. So you have two options: either you can model the staircase, or you can just provide the load of the staircase on the landing beam. Whichever is easier to you, you can do that. Then you have to define load patterns, diaphragms, and mass source, which is very important. Then these are the parts of the load applications, and meshing of slab is also very important here. And then we have the lateral loads. Dead load and live load are the vertical load, they act from top to bottom, and the lateral loads like earthquake loads and the wind loads, we have the codes associated with it, and there will be detailed explanation of all the necessary clauses of all the codes. And then we have the load combination. It's 75 part 5 load combination. And then we have the design checks, which is the standard checks which you have to do after every design. And after that comes the structural detailing. So structural detailing is basically when you prepare the structural drawing, and for the preparation of the structural drawing, the data which you need is the structural detailing. So we'll cover all that in this course. So let's proceed. So the first step which we'll have is to create the grids according to our plan here. So we have our plan, we have one secondary beam, and these are the grids here. So let's create the grids. And so first of all, we'll go to file and we'll click on new model and use built-in settings. Make all these settings as per your country's code. You're designing by Indian code, so all these things make by Indian code. So just click on OK, and after that you obviously will go for a custom grid spacing because you have a plan. Now you observe this grid ABCD. So first of all, simply let's give the ABCD from here. So the first distance is 3.573. so we'll simply write here in place of this 3.573, and then the next distance here which we have is 3.820. so we'll just add 3.573 plus 3.820. okay, just 3.573 plus 3.820, enter. And then the next distance is we have a secondary beam here, so we give the distance here. You can also do by offset option, but let's go by this option. So it is 1.610 from here. So I'll just copy this and paste it here. Okay, copy and paste. Let's write it 7.5 7.393 plus that is 1.610 enter. Okay, I've entered 2 points, that's why 7.393 plus 1.610 enter, and we'll add another grid here, and this one will be previous data plus 3.985, so it will be 7.393 plus 3.985. Enter and click on add the last data 3.573, so it is 11.378 plus 3.573. So these grids are done, and now this grid, if you notice here in this, you zoom in and notice here, this starts from 1 2 3 4, that is, it is starting from the bottom. So we'll start from the bottom as well. So bottom, let's see here, first distance is 4.6, so just add here 4.6, and then the next distance is 1.5, so 4.6 plus 1.5, and the next distance is also 4.6, so 6.1 plus 4.6, and so these grids are created. Just click on OK, and then custom story data, edit story data. Here we'll do 1.9 meter. This distance is equal to the, I'll show what the distance means because a lot of people have confusion. So this distance means the plinth height plus the foundation depth. 1.5 plus 0.45, like I can say around 1.95. Let's take 1.95 here. Okay, so 1.95 is this. Here we'll do minus 1.95. So I want to keep this base as this your foundation level, and this one as plinth level. You can also do PL here, and this one as story 1, like this also you can do. You can change this story 2 and story 3. Okay, like this you can do, or you can change your names according to you. So floor to floor height is 3 meters for each floors, and the depth of foundation and plus the plinth height is 1.95. So this is done. The story colors also you can change, no need. So click on OK and then click on OK. So your stories are created now. So once your stories are created, now you need to define some things. So let's go to define and define material properties. So here the PSI is the material property of concrete. So I'll just modify this. You can also double click. So I'll just straight away do M20, the most commonly used for residential building, M20 grade concrete, and here modify property, you can change the concrete cube compressive strength FCK to 20. Okay, and click on OK. Can make other properties same. Unit volume you can make this 25 for the concrete. Okay, so concrete plus rebar, you can do this 25 and click on OK. So this is done, and you have to find the rebar. Now this is the steel, this is not rebar, this is for structural steel. Click on here, this is for rebar. So I'll do FE550, and here we'll change the property data, and yeah, we have defined some properties in Excel, I think. Yeah, yield strength 560, ultimate strength 600. So yield strength is 560, ultimate strength is 600. Yield strength is 560, ultimate strength is 600. Okay, click on OK, and then also here also click on OK. So again click on OK. So first thing you have done, define sections, then define your properties of the frames, beams, columns and slab. Okay, so first of all let me just take column. For the beam width I'll define 2. So first of all I'll modify this or the double click also will do. So I'll do first of all PB 250 cross 350 and 20 grade concrete. Width will be 250 and depth will be 350, and we'll modify the rebar. Here you can see FE500 already selected only for beam. You can change the cover to 30 and then click on OK. And once this is done, and then we'll click on OK here. Similarly, we'll add copy of property here and here, not this one. Select this one and then add copy of property. It should work. Yeah, it worked. So RB it will be 300 into 425. So this one was done here, okay, and width is 300, depth is 425, and rebar, this can see it was already set earlier, so no problems. Click on OK, and this is set. Now for the columns, concrete column, we'll just edit this concrete column here. C, I'll name C 350 cross 350 and simply modify this 350 and 350, and reinforcement modify, no need to modify, I can see already this is there, and clear cover is 40, so longitudinal bar around 3/3 face 5, so longitudinal bar size and area, this, if you just change this also, this will be changed, so you can keep 20 for now, okay, no problems. And then just click on OK. Click on OK here, and then if you don't click on OK here, this will not be saved, so just click on OK and again cross check, because sometimes this is not saved. So you can see this is saved, so you're safe. So you've defined material sections and defined properties. Now we'll define diaphragms also, okay. Spring properties will not required, not diaphragms. So now we have here, what are the number of floors here? 1, 2, 3 and 4. Out of this, in ground floor sometimes we apply slab or sometimes we don't. In residential buildings generally we have PCC over compacted earth, so we don't apply slabs. But in industries or places where the compaction is not possible, we apply slabs in plinth level as well. But here we will not apply slabs in plinth level. So if it is a G+2 building, then the number of diaphragms will be 2. Okay, so ground floor will not have any diaphragms here. Okay, so we can define that. Okay, so just we'll modify this diaphragm D1 rigid. Okay, add for this first floor, and then add new diaphragm for the next floor, and okay, so sorry, it will be 3 diaphragms. Okay, so click on OK. So 1, 2, 3. Except the plinth level, there will be 3. So for the G+2 building, there will be 3 diaphragms. So this is all set here, diaphragms. So next thing which we can define, section cuts we don't need. Functions, if we are defining time history response spectrum, we can do that. Then we can define mass source, but that will be in the loading part. So let's do the modeling first, and then we'll define mass source and the loadings and all separately. Okay, so now first of all we need to go to the plinth level. So click on this plan view, and by the way, I want to add another view here, that is the elevation view. That is preferable. Add new window here, and click on this window and click on elevation, and here we'll add on the first grid which is there. Just click on 1 and click on apply, and then click on OK. So you can see this is the elevation view here which is showing. So okay, remove the picture if required later. Okay, so now this is the plan. We have to click here and go back to the plinth level. So you can just use these icons to go to the plinth level here like this. So once you have reached the plinth level, and here you can use the option of quick draw columns. So we'll do columns first, obviously, and continuous columns will be there, and just choose the property of the columns which you have made. So C 250, 350, 350 the column which you have made. look into your plan and see which are the positions where you have columns, and precisely apply columns only there. It doesn't mean that wherever we will have grids, we need to have columns. You have to look into your plan and see in which places we'll have this columns. You can see here, these are the places which we have columns. You can see this pretty much matches this. Okay, so now you can see in the 3D view as well this thing. So then you go to the quick draw beams and column plan, and here first of all just choose the property of the plinth beam here. From here, plinth beam PB, this is selected. Let me draw the secondary beam first, pinned, and here we'll make the secondary beam first, and then we'll go for the main beams. This only make this as continuous, so moment will not be released in this continuous portions. So you can go like this. There we don't have beam here. Okay, we have it here, and we have one here. Obviously we have here and here and here. So the beams are modeled. You can also turn on the extrude view, and not this one. This one is the extrude view, and see the beams. If you want to see in the 3D view, you can see in the 3D view, and if you want to see in the elevation view, you can also see in the elevation view as well. Okay, so like this you can see. Next, let's go to the upper floor and we'll apply our columns there. So let's take the column here and apply the columns. You can also do it in other ways like replicate and all. I'm just applying, since it's a small building, I'm just applying this. Okay, no problems. And again I'll apply the roof beams, and then we'll replicate maybe for the next floor. Okay, so now this is done, and we will go to beams here, and here we'll just choose RB, roof beams. And first of all, again we'll define the pinned support. This is actually for the staircase, so it's a very important beam. And then we'll make them back to continuous, and then we'll apply the beams here like this, like this, like this, like this. So this is done here, and now we can go select this and go to display, okay, or view. Sorry, not display, here it is view, and set 3D view. First option is that set 3D view. I'll do this 90 and 0 and 0. Click on OK, and then I'll take the just click on escape. Okay, it may go back to the pointer cursor and select the things like this. You can see these things are selected here, and once these things are selected, we can go to edit, and we can go to replicate, and we can go to story, and this is story 1, so this will be copied in story 2 and story 3, and click before you click on apply, you can just hover over to apply. You can see the effect here in the 3D view of mirror window. Okay, so just if this is okay, just click on apply and OK. Okay, so you can see the 3D view in the extruded view as well, just to give you an idea that whether it is okay or not. Okay, so on the default 3D view, just click on 3D, it will go to the default 3D view. You can zoom in and zoom out. You can see this is the 3D view of the building here. Okay, so this is done up to this. So now we'll need to define some slab section. Beams and columns are done. We'll have to define some slab sections. So we'll go to define, and we'll go to section properties. You can see here slab sections. Okay, so you have slab 1. I'll just edit this. Okay, instead of slab 1, I'll do slab 125 mm. Okay, M20 grade concrete. No need to change this. Just change the slab thickness to 125 mm as per our plan. Click on OK, so that this is saved. So now we'll go, this is story 1, so the slab starts on story 1, and since we are not applying any slab in the plinth level, so we'll do it. So here you'll find the option of quick draw floor. Select this, and here you'll have the option of slab 125 selected, and you can simply just click and make the slabs here. So except the staircase, we have created slabs in all the portions here. Okay, the staircase portions we will deal with later. Click on escape and you can select all the slabs here. Okay, like this you can do one by one. You can select all, or there is another way. Just click on escape and click on select, and here you have these options here: select groups, stories, properties. Here slab sections 125, and click on select and close. So once this is selected, and you can go to edit and you can go to replicate. Okay, replicate and go to story. This is story 1, so story 3 and story 2, this will get replicated. Click on apply. Okay, so this gets replicated here. So like this you can see in the 3D model as well, the slab has been applied. So the next step will be to apply fixed support here. So you can see there are by default pin support available. What does this support denote? This support denotes the connection between the column and the footing. We are not designing footing here, okay, in this particular software, but this connection, if you do this fixed, this represents the monolithic connection between the column and the footing. So this can be done here, and for doing this we have to go to the base level. So let's move up. It will be easier to go to the base level in this way. So this is the base level, so we'll select this like this. All the base are selected, so we'll go to noted to define. In this case directly go to assign, joint, restraints, and select this fixed icon and click on apply and then click on OK. And then in the I'll just remove my picture here because this would be causing some disturbance here. Okay, now you can see in this elevation view it is not updated, since it is showing this icon. Simply click on this elevation view and go click on 3D first and then click on elevation and click on elevation, not plan. I have clicked plan 1, apply and OK. So now you can see, if you just zoom in here, you can see this is the fixed support here. So this is a graphics thing, it takes some time to change. So here now we have changed the support as well. So we have just select this and we'll go turn the extruded view off. So now comes the load of the staircase. So it is, you can model the staircase here, but practically even if for large buildings it's just better to create the landing beam and assign the loads there, because for a large structure, as just creating the staircase may take more time, and when we are not designing staircase here, we are only doing it for the load. So it's better if you just consider the load of the staircase in my view. Okay, you can try make a video on the creation of staircase also, but in this video we'll just assign the load. We'll create a landing beam and we'll assign the loads of the staircase on the landing beam as well as the roof beam, which will be above it, and we'll also tell you the procedure. And you can also relate it with this by the theory which of design of, that is theory of the design of staircase, which you have studied already, I believe. So we'll do that. So you can see the staircases here. We will see in the architectural plan, you can see the mid landing will come here in this particular portion, though that it will come around here in this grid, that is the grid 1. So you can see the grid 1 is here, and if I select this beam here, this particular beam, and if I just copy it down below, then I can create this. So let's just know the height where the staircase mid landing will be. If I can be able to know that, so it is dog leg staircase, so it will come at the middle, that's 1.5 around. So if I can do this offset at 1.5, then I'll be able to make the landing beam. So we'll go to define, we'll go to draw, and we have this option of reference point, draw reference points. Okay, so in the Z direction, if we are going to select from bottom or top, for the matter, 1.5 meter from the bottom, and I'll just select this particular point. You can see, it is selected here. So there are many ways in which you can do this. So the best way is the creation of reference plane. So if you go to draw and reference, we have this option of reference planes, and let's go with 1.5 meters. So that will be in mm, it will be 1500, and simply select this plane as reference, and the reference plane will be created. Then you take a beam here and just draw your beam. Let's go with the default size of 300. Let's go 215 to 350 beam, not this one. 215 to 350, and take points from here to here. So once you take this, once this is done, and you can then copy to the other reference plane as well. So it's better if you just create the reference plane in one go. Go to edit, draw, and go to reference planes, and here 150, this is in mm, right? So 1500, and then you create a reference plane here and a reference plane here. So then we can easily go with the thing here. Click on escape, and again take this. So this is joint. So now we have applied the landing beams, okay, and if we want to apply the loads on this landing beams and also the roof beams here, so we can do that easily. So you can say the modeling part is done. So you can take a screenshot of this. This is the load of the staircase, so per meter square. So if there is a one flight, that is in this case in our roof beam, in this particular beam there will be one particular flight, and then it will be 10.4 kilonewton per meter square, and in the landing beam the two flights will be there, so it will be 20.8 kilonewton per meter square. So like this we can assign the loads in the landing beam as well as in the middle beam. So we can do that. So then we can assign the diaphragms. So let's move on, and this is the zero blend level, and let's move on to the first floor level. And in this first floor level we can go defined diagram is already there. So we can select this like this, and then assign shell, and here we'll assign the diaphragms. So we'll go to assign shell, and here diaphragms. So firstly let's apply D1 here. Click on apply, click on OK, and then we'll move up and this floor, okay. So select this like this and assign shell, diaphragms D2, apply and OK, and then move up, select this and assign, and then assign shell, and then diaphragms D3, apply and OK. So diaphragms have been assigned. So now we'll go to the loading part. So go to define, and here up to diaphragms we have defined, and then we will define the load. Let's click load combination. We will need load combination after our defining a load pattern. So click on load patterns here. So you have two default load here. So dead load is here. So this dead load, I'll treat this dead load as a self weight, and all other parts of the dead load I'll include in other dead load. Okay, so I'll just select here other dead, in which the self weight multiplier will not be there. Okay, so it will be 0, and I'll click on add new load. Okay, and live load will be there, dead load will be there, and let's add a seismic load here. Okay, so add new load. It will name it as seismic, or just do SL X. Type, it will be a seismic here, seismic, and auto load multiplier you can add later also, but let us add the latest code, Indian code, which is there. 2002 is the latest here. Let's see. Okay, actually 2016 is the latest, but this in this version only up to 2002 is there. Okay, let's select 2002 and add new load, and SLY here will add new load, and I'll just do WL for wind load, and here this will be type as wind, and obviously we'll select the 875 part 3 here for the, yeah, this 2015 875 will select for the wind load and new load. Okay, so this is added dead load, other dead load. So before, just click on OK here to save this. Before doing that, let's clear the theory part. So loads of staircase we know. Now the dead load. So if you go in let's say, sorry, this one, that is I can zoom in. So if you can go in this dead load part, so dead load is denoted by table number 1 of 875 part 1, and if you can see here in this 875 part 1, there are various, in the option of 7, the PDF, you can see page number 33, because you will download PDF only, right? So in flooring option there are different kinds of flooring. So the unit you can see here, kilonewton per meter square. So flooring is given in kilonewton per meter square for 10 mm thickness. Different types of flooring are given. So you need to know which type of flooring you are going to provide. So for that, this normal clay floor tiles of thickness between 12.5 to 25.4, which is okay, and the floor finish is between 0.1 to 0.2. So there can be any various kinds of tiles, terracotta, terrazzo, any kind of things can be there. So you can see there are the various weights. So for safety, I can consider 0.5 for this floor finish load, 0.5, but if there is any different material, you need to consider floor finish differently. Okay, so you need to know this. Okay, and then we have, okay, we have talked about the self weight. The self weight only we need to provide the direction. The self weight of all the structural members, the software will take automatically, beams, columns. And then we have the load of the wall. So the load of the wall acts on the beam, so we have to calculate the wall load. Now the wall thickness here is, if you see in the plan, the wall thickness here is 125 mm. Okay, you see the wall thickness 125 mm everywhere. Okay, it can be different, so you need to understand this calculation. So for your particular building we can do this. Okay, for different plan also. 3 meter, considering 0.3 meter beam, that is roof beam. If you consider 0.3 meter, then the height will be reduced for up to 2.7 meter. Remember, if there is similar floor or for the main beams only, this will work. Otherwise this might not work. If this is similar floor, you can consider 3 meter itself, no need to deduct. Okay, the brick thickness is 125 mm. Plaster thickness, if you take like 12 and 6 mm, approximately it will be 25 mm. If you have taken unit of brick in 875 part 1, you will find this 19 and 20 for mortar, and then we have to just multiply. There is two lengths and the unit weight, and multiply and get the unit weight of wall. And for the parapet wall, the height is less, about 0.6 to 0.76 to 0.8, so it's around 2.3 kilonewton per meter square. So now we can apply these dead loads, but in the places where we'll have like beams of staircases, we'll add the staircase load from here on the beams. Okay, so that's simple. And for residential building, and you can see here in this residential buildings, for the live load in table number 1 in 875 part 2, live load is given, and for various other buildings there are various other loads which you need to see in this table number 1. So this is the live load, you need to apply this live loads, pretty simple. And then we have the design check, so we'll do it later, live load. Okay, let's apply these two, and we will just do this later. Okay, let's see the seismic load as well. Okay, seismic load as well, we'll see. Okay, and we'll see in seismic load code is 1893. Okay, so first of all, go to define and load patterns once again. So dead load, it will take automatically, and live load will assign, and other dead also will assign one by one. So let's start by live load. Okay, live load will assign first, will apply on the slabs. So there are slabs in 3 levels. Okay, so let's select here them first. First of all, make sure anything is not selected, click on escape, and again go to select, and then by properties, and slab sections, slab 125, select and close. We need not close also, and then after that we go to assign shell, and okay, shell loads, we go to shell loads, and then we have uniform. Uniform, let's apply other dead load first, that is we will apply floor finish load here 0.5. so direction is around the gravity, so this acts around top to bottom gravity. Click on apply, this is applied, and now simply just click on live, and live 2 kilonewton per meter square will apply here. Okay, click on apply. Okay, so this is showing that we have no selected object, so to select again, right? So simply go select, and select by properties, by that is slab sections, and then select the slab once again, select, close, and then assign shell loads uniform to live and apply, and now it is applied. You can see here it is okay. So whatever the active window, it will show on that. Okay, so this one was the active window, so it is showing on this. So this is applied, live load is has been applied here, and other dead has been applied. Now time to apply the load of the walls. So let's go to the bottommost level here first. So here we'll apply the loads. So the load which we got calculated was, let's see, unit load of all 8 kilonewton per meter square. So it will act on all the beams here, because all the beams have walls on them. You can see here on this plan. Okay, almost. So let's add here. So we'll select the beams here, so we can select the beams. Let's go select from here. You can select the beams here like this from by properties. Okay, or let's do this, select the beams like this. Okay, okay, so all the beams are selected, and then go to assign frame loads and distributed, and we'll apply dead load here, and dead load will be 8 points. What was the value was 8. Okay, we'll apply 8 here, since in the gravity direction 8, and click on apply, click on OK. Okay, so only one was selected. Oh, this was okay, this was not the landing level, sorry, my bad. So press Ctrl plus Z. Okay, just remove this. We'll go to the bottommost floor, or else you can simply go to make this easier. Since I made a mistake, to make this easier, better if you go set plan view, and you go to the desired level. So the plinth level I want to go, click on to apply, and okay. So we'll work on this first. So yes, so let's select the beams here like this. Okay, the beams have been selected, and then we'll go to assign frame loads distributed. Here it is, the value is 8. Okay, so 8, let's apply 8 and click on. So it will be in other dead, it's not the live load, so it will be another dead, and click on apply and OK. Okay, so wall load we have applied, floor finish we applied, self weight it will take automatically. So dead load part is over, and also the live load part is over. Now moving on to the seismic load. So we'll go to define, and we'll go to the load patterns once again to just correct the seismic load. So seismic load in the x direction, modify lateral load, So I'll take all y direction here, and now we'll understand this. What is this? First of all, what is it? Is eccentricity ratio, and then it is bottom story is should also always be the plinth level. So plinth level. Now response direction factor. How will time period will be user defined. So we'll see all this. So first of all, let's come and do the seismic zone factor. So okay, seismic zone factor. So you'll see I have made a PDF for this. Let me just open this. Okay, so response spectrum will study later, not for this video tutorial. It's a more advanced thing. So first of all is the seismic zone, and let's see zone factor. Yeah, so Agartala, Tripura is in seismic zone 5. You know, you can file a table below, and also there is a map, and for the seismic zone 5 the factor is 0.36. So if according to your seismic zone, you select the value from here as per the table as per the table number 3 in the IS 1893. Okay, so that thing clear. And the second is site type. So for the site type, you can see there is, so actually site type was in earlier code. According to this particular type of soil, you can see the 3 types of soil are there: site 1, rock or hard soil, medium. So if you want medium soil, you can simply select site type as here you can select site type as 2. Okay, and then comes importance factor. Importance factor, I have written the PDF here. Importance factor. So importance factor here you can see is in table number 8. So in table number 8 there are 3 importance factors mainly, and it is 1.5 for all public buildings basically, and if the building has more than 200 but normal residential building also, then it will be 1.2, that is like apartments and all. And if there is normal other residential building and buildings of lesser importance, then it is 1. So this is a residential building and not less than 200, then we'll go with 1 here. And then what we have here, this thing we are covered. Okay, damping ratio also we have covered. So what is this? Yeah, damping ratio, eccentricity ratio, this is 0.5% is taken. You can see as per this code, in this you can see damping ratio, the value of damping is taken as 5% as per clause number 7.2.4. okay, so it is taken 5%. So it is as per this. So as per code you can get all these values. And now finally the time period. So time period I'll show you as per the code, the time period. So this will help in the response spectrum analysis as well. Prepared this originally for the response spectrum analysis. So all this, if you do this properly in the static analysis, then in the response spectrum analysis it will be helpful. So in the clause number IS 1893/2016 clause part 1, clause 7.6.2, there are various kinds of buildings given. So the building which you are preparing is an RC moment resisting frame, special moment resisting frame, because you are considering ductility, and it falls under all other buildings. So this is the formula, and according to formula, the height of the building, remember, always taken, that is 9 meter, 3 floors are there, and plus the plinth height. So height of the building is always the building floor to floor heights plus the plinth height, and the headroom may be excluded from that if it is up to 2.4 meter. That is the general rule. Okay, so 0. And the direction in the length in the x direction for this building is 15 and y direction is 11. So these are the values of TAX and TAY and 0.22 and 0.26. So since we are considering this in the x direction, so it will be 0.22 seconds. Okay, simply click on OK here and modify lateral load for the y direction. Now here all the y will be rejected, and importance factor, this is okay. This will be plinth level once again, and for this user defined, and user defined our value for this is 0.26, right? 0.26. If you don't take, then it will just calculate automatically. Okay, so this is the seismic load in x and y direction, and I'll just click on OK once just to save this, and then we'll move on to the wind load. Okay, I'll discuss the wind load in detail sometimes else, but now just consider this wind load and modify lateral load. Okay, So you can see the wind direction. So basically 0 is for 0 is for x and y is for 90. So you can see the all the width and all they are taking automatically here. Okay, and CP and this CP values, wind load coefficient and leeward coefficient, you can modify. There is a table in the code, we can modify from there, and basic wind speed is also there in the code. Terrain category, we have this terrain categories, different terrain categories are there. So you can see this is a risk coefficient for different wind zones here, and this is table number 1. I'm just showing the important clause. Okay, and these are the terrain categories and the factors, and we have this basic formula for the wind load topographic factor. There is three factors actually: K1, K2, K3 and K4. So in the new code there is one K4 as well for the cyclonic areas. K3, if it this it is taken, the upward wind slope is up to 3 degrees, then the K3 can be taken as 1. It varies from 1 to 1.36 here, and basically this is the formula: VB into K1, K2, K3, K4. So design wind speed, you can see there are in the code there is given for different regions: 50, 55, 45, like this. So I'm taking as 50 for Agartala, and K1, K2, K3 is the multiplier. So if all of them are 1, then VZ or the design wind speed will be equal to VB. Otherwise there will be some vector by which it will be multiplied. Okay, so this is the case here for this. So we can see the terrain category. Category 1 is exposed terrain with few or no obstructions, and category 2 is the second stage, like outward park. So there are some obstructions. Category 3 is very many obstructions, and category 4 that is been very like a city or a congested land. So if it is an open land, that is like category 1, and then there will be more exposure to wind load. So I'll take in this case category 2 for this. Okay, so terrain category 2, I'll take importance factor 1 and risk coefficient K1, K2. Since this is not the updated software, so K4 is not there. So if K4 is there, then it will be your 1 only. So we'll take this as a plinth level, and we'll click on. This is important. This you have to select exposure to the extents of diaphragm. Since we've already defined diaphragms, so we don't need to assign shells or any kind of panels like this. Okay, for this. So just click on OK and click on OK here. So the wind load has also been defined. Now the next important thing is to define the mass source. The mass source, for the mass source, I'm also made many videos on the mass source, but very important concept of the mass source is this. You can see in the IS code 1893 what is the seismic weight of the floor. Basically you can read this. Basically it is only the the dead load, the full dead load, plus a percentage of the live load. So why does this how do you know what percentage of the live load you should take in the seismic weight of the floor? That is comes from table number 10. In table number 10 it is written, if it is up to 3, then we take 25%, and if it is more than 3, then we'll take 50%. So the definition is pretty simple, so let's create it. So we can modify this. Let's see. Okay, let's let's modify this. Okay, and just cancel and delete this. Okay, mass source, add new mass source here. Okay, and here okay, specified load patterns I have to take. Oh, sorry. Okay, so just open the seismic mass source and we'll modify this. Okay, modify and click on this specified load patterns. So first of all we want to add the dead load. So dead load 1, click on add, and the other dead load multiplier will be 0 because there is no dead load here. Okay, so there is also this will also be 0, or sorry 1, because the full load of the self weight will be taken, and the full another dead load we have included floor finish will be taken, and the wall loads will be taken. These two loads are taken, and then for the live load we'll have the multipliers. Okay, now for the live load, our live load is 2, which is as per the code you can see it is will take 25% in the seismic mass, so it will be 0.25. so click on add. This is done. Click on OK. Okay, so Now the mass source is done, and click on OK here. So seismic mass source has been defined. Now seismic mass source is defined. Now for the dead load we have assigned only at the plinth level, so let's assign this dead load in the other levels as well. Okay, so we'll go here, click on the plan view first, and go to view and set plan view. The best way to move around here, let's look at open this first. Now this is the beam. In this beam, landing beam, there will be two flights. So select this first and then click on assign, and after click on assign, go to frame loads distributed. So here this will be on other dead only. Here the dead load, you can see here, let's see from here, the dead load will be for the wall load it will be 8, and so for two flights the load will be 20.8. so let's apply 20.8 here, 20.8, and then click on apply, click on OK. So this is done, and we'll go to the next level. Okay, so go to view and set plan view, and this next level is story 1. Click on apply, click on OK, and here in this particular plan, just select all the beams here. Okay, so for selecting all the beams, let's select everything, and then go to select, click on deselect, deselect by properties, frame sections, deselect the columns first, and then we'll also deselect the slabs. Okay, first of all let's select this, sorry, deselect, and then close, and then go to select here, deselect by properties, slab sections 125, click on deselect, close. Okay, so here all the things are okay, but for this particular area we'll just untick this. Okay, because this load will assign later. Okay, we'll assign later. For all other beams we'll have a similar load. Okay, go to assign and assign frame, and frame will have, sorry, frame loads distributed, and this will be our 8, and click on apply and click on OK. And for this particular beam we'll go select this and assign frame loads distributed. It will be 8 plus the staircase load, which is 10.4. so let's go 18.4, right, 18.4. click on apply, click on OK. This is done. Now this is done, and then we can do this for the other floors as well. Okay, so now let's move on to the next. Just click here and go to view, and you can simply go up here, I think. Yeah, just select this and we'll apply the landing slab load, and assign frame loads distributed, that is 20, what is the value, 20.8, 20.8. click on apply, click on OK. Then let's move up and again up, and this one also select and assign frame loads distributed 20.8, apply. Okay, so applied on all these three, and let's apply, go to the next floor here, bottom floor, this one. Okay, let's see if you can copy all the loads here. Okay, so same procedure let's do again. Select this. Okay, go to select, go to deselect, properties, frame sections, columns will be deselected, deselect, close, select, deselect, properties, slab sections, 125, deselect, close, and simply click here and then assign frame loads distributed 8, apply, OK, click here, assign frame loads distributed 18.4, apply, OK, and then we'll go to the topmost floor. Better it is 9. Okay, this is 9, this is topmost floor. Okay, so in the topmost floor we will go to select all the parapet walls. Okay, we'll select the walls like this and walls like this area, and this area like this, except the staircase portion. This is selected, and go to select, deselect, and then object type, columns, deselect, close, right, and then click on assign frame loads distributed, and the parapet wall load is, we'll take the value from here, 2.3. so 2.3 will be applied, 2.3, apply, OK, 2.3 load is applied here. And for this portion, okay, go again, select, deselect, properties, by properties, object type also you can do, columns, deselect, and we'll go to assign frame loads distributed. Here will be same, because there will be 10 inch, this 5-inch wall. Okay, and OK. So this is the assignment is done. Now you can check the loads here. Let me check here. So here you can see display load assigns, shell load, dead load you want to see, other dead, apply. Okay, here you can see here other dead load is, okay, let's see in the 3D view. Okay, click on the 3D view, display load assigns, shell loads. Let me see live load is assigned or not, apply. You can see live load is assigned everywhere, and the other dead, apply, other dead load is also assigned. So the load assignment has been complete. Now after the load assignment is complete, you can create a load combination, define, and here you can go to load combinations, add new combo. You can define manually. If you want to define default combos, just go to concrete frame design, and then click on, you can edit, convert this in editable as well, click on OK, and then click on OK. So load combinations have been defined here. Now let's select all these slabs here. Go to the 3D view and go to select, and select by object type. You can go and floors, no, floors you don't want, you want to select by slab section. Let's select by properties, then slab sections, slab 125, select, right, and then we close this, right. So then we go to assign shell, and then we'll mesh. Okay, so we'll go with the floor auto mesh options. Then we'll have the, you can just define the meshing object types 2 by 2, and you can auto code also you can do various options are there which you can do. So simply you can click on apply and OK. So now if you want to see the effects, just click on the 3D view, and you have this option of set display options. Here you have the option of shell analysis mesh. Let's click on apply and let's see what happens. You can see the mesh is visible here. So like this you can make the mesh your visible. Then if you want to mesh the frames as well, just select here on 3D view and go to select, and here select by object type. Object type will go beams and columns, right, and then select them. Okay, after select them, make sure to click on close. So then you can go to assign frame, and you have this frame auto mesh options. Here you have this option, that is auto mesh at immediate joints here, okay, and automated intersecting frames, and okay, just click on apply and the meshing will be done automatically here. So the meshing is done, and after that you can go to assign once again, okay, go to frame once again, and here the second option up below this is the frame floor meshing options, okay. So in the frame floor meshing options, you can just see, you can see that the grad previous selection option is there, okay. So all the previous things are now selected. So include selected objects in mesh and click on apply and then click on OK. So once this is done, your meshing is completed. So now you can check whether your model is okay or not. So go to analyze, check model, and go to select all, select all, and then click on OK. So then the model will check. So you can see there is warning in the element here, so you can have to correct that. So mask source MSC has both element and self-centered mask and load pattern 1, so you can fix that, okay. So what happened is define, go to mask source and modify mask source, okay. Element self mask should be deselected because already I have included the element self mask in the dead load, okay. So this should be deselected. So, or if I include the element self mask, then I should not include the dead load here, okay. So that was the mistake. So this is done, and then click on OK, okay, then click on OK once again, and then you can go to analyze, check model, and again OK, and let's see if the thing is corrected. So model has been checked, no warning messages were generated, so this is okay. And then we'll go to analyze, and we'll go to run analysis, right, run analysis. Then you have to save the model here, okay. I'll just name this, and then we'll save the model since I have not saved it earlier. So then it will run the analysis for you. So the analysis has been completed. Now let's see the results one by one. So let's see in the floor view this results here. So we can see this is the display support reactions here, okay. So you can see display the deformed shape force stress diagrams. Let's go shell stress forces here. You can select any load case here or any load combination also you can select, okay. Or if even analysis like any load combination also you can select here, like any load combination select here, and then you can go with any kind of load here and click on apply, and you will see the stress here. So particular load case, suppose I want for the other dead, and then click on apply, it will show for the other dead as well. Now you can see shell stresses here, visible force, top force, bottom force, absolute maximum, okay. Click on apply, you can see the shell stresses due to this, and there are other components as well, and which you can visualize here. And you can also observe the changes in the floor wise. You can just move up, so you can see here in the 6 at the stress is in the green zone, and if you move up the stresses that is in the 9, the stresses are that is in the yellow zone. So it is 0, so it is changing in various levels here. You can see how it is changing, okay. So like this you can observe one thing. So now let's see the shear force bending moment best seen in the elevation view. So select the elevation view here, and you can select directly from here, or you can go to display, and you can have this force stress diagrams, frame spindle diagrams here, and let's take for any load here, okay. Moment 33, okay. Click on apply, you can see the moments here. You can see, let me just, you can close the 3D view for better just understanding. You can see here, if you want this field diagram, you can select this. If you want the values, click on the values, you can see the values as well, okay. I'll just get rid of the values now, so you can see. And shear 22 is the shear force diagram, and the axial force also you can see the axial force. So like this you can see the shear force. So if you want to see the deformed shape here, So we'll go to display and display deform shape. You can just see the deform shape due to, let's say, any load case to with this, and you can click on here. You can see the display draw contours. You can see like contours will be drawn. Just deselect and the contours will go. You can see the deformed shape here. Scaling also you can increase also. Okay, and if you want wire shadow, like just like this also, you can view the deformed shape. So now we can design. So we'll go to design here and concrete frame design, and you can revise your preference or simply just go here and click on design check. So the structure will be designed. So once the structure is designed, you can see the AST here. So this is the AST at the top. AST is there, bottom AST is there. So like this you can find the area of steel which will be required here. So you can see you applied the staircase load here, so this is a little bit different here. So you can see in some places the moment is more at the top, so the top reinforcement is more. In some places the moment is more at the bottom reinforcement is more. So you can see the AST like this. In some places there is, it is equal, there is 244, it is equal. So you can see the AST like this. Okay, so there are some checks which you need to do. First of all, you will check whether all members passed or not. Here you can see in the concrete frame design, if you just scroll down below, and there should be an option of verify all members passed. So all frames are passed. So if there is any member failing, you need to just increase the size of that particular member to get it passed. So the next check which we have is the rebar percentage check. So first of all, let's know what the IS code says about it. So first of all, the rebar percentage for, let me switch to reading view. Okay, so the rebar percentage for the beams is minimum area is given by you can say 0.85 or 85% of the cross sectional area divided by Fy. Fy in this case is 550, that is dependent on our steel. Okay, yield strength of steel. So it is the minimum area, and for the beams the maximum area is 0.04 BD. You can see in the clause 26.5.1 of the IS code here. You can see this is the clause. So 4% of the cross section area is the maximum, and the minimum area is given by this. And for the columns, which is given in this particular clause, page 261 of the PDF, and here the minimum area is 4% of the cross sectional area. Maximum is 4% of the cross sectional area, and the minimum is 0.8% of the cross sectional area. So we'll see in the plan. So these are AST values in mm square. So if you want to, let's see the values here of the rebar percentage. So you can see here there is the option of concrete frame design. In this you have the option of display design info, and in display design info, display concrete frame results, here we'll do rebar percentages. Click on apply. So now we will have percentages here. Okay, so you can see the percentage here. The column, it is 0.8%, so minimum reinforcement is provided here, 0.8%. And let me just close this, it will be better for the view here. Okay, it's better. So the values of the concrete, you can see all are 0.8%. So the minimum reinforcement is provided. So 0.88%, you can see these are the values. So these values lie in the range. Also you can check for the beams also, the percentage beam, for the beam percentage, maximum percentage you can check easily. 4% is there, so you can see all are less than 4%. So like this you can check the minimum reinforcement and maximum reinforcement for the beams and columns. So the next check which you can do is the PMM interaction ratio. So first of all, I'll just switch to the 3D view for this one, as it will better represent 3D view. So here we will go again to the same thing here, that is display design info. So in the display design info everything will fine, and here this is the PMM ratio, so it must be less than 1. Click on apply and click on OK. So you can see every column is in the range of 0.9 to 1. So 9, it is kind of design ratio. So if it's more than 1, then it is overstressed. So all our columns are within the appropriate range, so we are good to go here. Next thing is the BCC ratio. So simply go again to this one particular thing, and here display design info, and you have this BCC ratio. So the BCC ratio should also be, beam column capacity ratio, so this should also be less than 1. Now in IS 13920, okay, this is the code for ductile detailing, and the latest part, there is a 2016, you will find in clause 7.2 the beam moment multiplier is 1.4 in this case, and 1.4 should be minimum. And there are also various other things as well, but here, so by this we can see here the most of these things are, minimum is 1.4, so it is 1, and it is 2, 1.8, 1 in the bottom floors, so it goes higher here, so it is okay. The theme is, if the not enough loads are being transferred from beam to columns, then the column becomes less useful. So that is the theme, so that is the thing which you can learn from here. Okay, so anyway, let's move on to the next check which is required. So the next check is for the story drift. Is per the earthquake code, the IS code for the earthquake, the maximum story drift should not exceed 0.004 times the story height. So in our case, the story height is 3 meters, and 0.004 into 3 is 0.012. So let's see if anything exceeds 0.012 meter. So we'll go to the model here, and there are many ways. Let's go for the easiest way. Display, and display, here we have show tables, and in show tables go to displacements. It will be like this first. Okay, it will be like this first, analysis, and then you have to open the results, and then the displacements, then we have story drift. So story drift, click on OK, and then many things will come. You will just select this, right click here, and only select SLX and SL, SLX1, SLX2. okay, actually there is SLX and SLXY, X and Y, so just select this two and OK. So only these two values are there. So here you can see the drift values, so all are less than 0.01, so these are all safe in drift. So this check is fulfilled. So next we need to check the torsional irregularity should be less than 1.2 for the building to be regular. Okay, otherwise it should be considered as an irregular structure. So this building will be regular, this is pretty much a regular structure, but let's still check to know the process. So first of all, we'll go here to the plan view, so that it is easier for us to check. We'll go to the topmost story, plan, and click on OK. Now we want to view the deformed shape here, and display here deformed shape, and in deformed shape select one of the seismic loads. Let's take in X direction first, and click on apply and click on OK. So deformed, for deformed we'll click any 2 points. Okay, so first of all, let's right click on this point, and then you can see it is 4.22. so I'll calculate the average of two ends here. Let me just give a bracket. It is 4.22 plus, I'll make the average. Okay, and then in this point and in this point also it is 4.22. so 4.22 plus 4.22 by 2, the average drift is 4.22, and the maximum drift is also 4.22. so here 4.22 by 4.22, this will come as 1. Okay, in this end also, bottom end also, you can see here it is 4.23, and in this end it is 4.23. so again the maximum by average is 1, so it is less than 1.2, so this structure is regular. So the maximum displacement by the average displacement of any two ends should be less than 1.2 for the building to be regular. So the building is a regular structure. So these are the checks which we can do here. So this ends this particular tutorial series, and in this if you like this video, make sure you like it and keep practicing. And if you have any kind of doubts or queries, you can comment below, and there are other videos in the Etabs playlist as well. You can check and keep learning, keep growing. If there is any new thing which comes up, do let me know in the comment section. Thank you. Bye bye.